Soil can be found on most land surfaces and can be a mixture of many things. Maybe you've noticed soil looks and feels different in different places. Here's why.
Below the surface of the earth lies solid rock. You can see this rock in many places in Utah. And can it ever be beautiful? Whew. Geologists and soil scientists, people who study rock and the forces that shaped our land, call this solid rock parent material.
Speaking of soil, this is Bob Raisley. He's a geologist.
Tell us, Bob, how do we get soil from parent material?
Over billions of years, the rock of the planet breaks down into smaller and smaller rock fragments, forming the soils we have today. The soil layers form from the different kinds of rocks, ocean bottom, land rocks, and create many, many different kinds of soil profiles. This is a general soil profile.
Why isn't it all just dirt?
It's not all dirt because it actually has structure. We've got three different layers here inside the soil profile. The lower part of the profile is called the parent material. It's where the rock actually breaks down into smaller fragments and then breaks down into even smaller fragments to form the middle layer, which is the subsoil. That's the zone that the animals burrow into. They can get in there and create their burrows. That's where foxes, rabbits, and even some owls live. Inside this layer, plants put their roots to hold themselves up and steady. Big trees grow down into this. And on the top layer, that's a combination of this layer, the subsoil, and the rotted plants. It's the living zone where plants grow. And it's the area that we live off of, all the animals live off of. Without that, life on Earth wouldn't be particularly possible.
Well, how long does it take to make an inch of topsoil?
An inch of topsoil takes roughly about 1,000 years.
Wow.
It actually is even longer for the entire foot of topsoil you see represented here. That would be 10,000 years. The rock that makes up the base of the topsoil takes around a few million to hundreds of millions of years to create. The rocks in Utah predate or are older than the dinosaurs. Utah geologic history is a history of planetary climate and rock building processes. Utah has been in and out of water many times over its geologic history and has been host to almost all forms of life known on Earth. The evidence of this rich history is in Utah's rocks and soil. There are sandy, rocky soils in the Uinta Mountains composed of nearly 1 billion-year-old floodplain sediments. The top of Mount Timpanogos is composed of 500 million-year-old ocean coral reefs at 11,000 feet in the air. Caves have since formed in that mountain. Bryce Canyon's red and white beauty is the result of ancient lake deposits. Zion's and Arches national parks are composed of hundreds of feet of fossil sand dunes of a large ancient desert. The Colorado Plateau and Canyonlands hold some of the world's most interesting fossils, the dinosaurs. Mixed in with the dinosaurs are rocks of periods of time when the area was under seawater. These rocks weathered to salty soils in the Book Cliffs of Price and Green River area, and into the red soils of the southern tier of the state near St. George and Kanab. The climate of the last 10,000 years has been most important in forming the soils of Utah's modern surface. Ancient Lake Bonneville covered the western half of Utah and left its clay, silty soils in the valley bottoms, including the Wasatch Front. Glaciers covered most of Utah above 8,000 to 9,000 feet and left sand and boulder deposits on the mountains and in the canyons. The soils we have are the product of billions of years of geologic process and the most recent climate in Utah. And yet they are an extremely fragile resource. We're losing our topsoil at 15 times the rate that it's being made.
Well, thanks for coming by, Bob.
Yeah, we'll see you in a little bit.
Yep, we'll see you. You're welcome.
In Utah and most western states, our topsoil is only 1 to 12 inches deep, and that's not much. Our topsoil layer is shallow. Farmers, ranchers, and others who use the land must be careful to help hold topsoil in its place, keep it healthy, and even build up topsoil for future generations.
But because it can take hundreds of years to build a small layer of soil, it's classified as a non-renewable resource. Once our good topsoil's gone, it's gone.
Now for the nitty-gritty. Topsoil is composed of three basic kinds of matter: solid stuff, liquid stuff, and gases. The solid stuff accounts for about half of the volume of soil.
The solid particles in soil are mostly minerals. Minerals come from the rocks that have broken apart because of water that flows into the cracks of the rock and then freezes.
When water freezes, it expands, so tiny little bits of rock are broken off. When the water flows again, it carries these tiny bits away into the soil. Also, plant roots can grow into soft rock and break it apart.
Chemicals can break rocks apart too. Many rocks are broken apart by lichens, tiny crusty plants that live on rocks. Lichens come in many colors and give off an acid that breaks down the minerals in the rock.
Mineral matter takes up about 45% of the total volume of soils.
About 5% of soil is organic matter. Organic matter is dead, decaying plants, insects, and other stuff that used to be alive. This is composted cow manure and straw.
Organic matter is usually located at the top of soil. As this organic layer decays, it supplies nutrients to help the plants that live in the soil. This organic stuff is what makes soil fertile.
These particles of solid minerals and organic stuff fit loosely together, leaving room in between. The space between solid particles is filled with gas in the form of air and liquid in the form of water. If there is little water in soil, then the space in between will be filled with air. But when rainwater soaks the soil, the air is replaced until the soil dries out again. Because the weather is always changing, the amounts of air and water are always changing too. But an average soil contains about 25% water and 25% air.
Water and air in the soil are very important to the plants and animals that live in the soil. When plants suck up water, they also take in nutrients like iron and nitrogen. These nutrients come from organic matter. Plus, lots of organic matter helps make sure that the soil stays moist.
Let's compare soils that are high and low in organic matter.
Organic matter holds moisture by absorbing it. This sand in this container has very little organic matter, so it holds very little water. It drains and dries up quickly.
But when soil has lots of organic matter, it holds more moisture. Plus, these kinds of soils don't pack down as much. Now, even though all soils share common ingredients, the actual combination of particles in soils can vary a lot.
Most soils are a mixture of large particles commonly known as sand, medium-sized particles called silt, and smaller particles called clay.
Ooh, that looks like a dirt milkshake. And holding it is Deborah Spillmaker.
She teaches kids about agriculture, and that's pretty darn close to the dirt.
You're right, it does look like a dirt shake. But if you let it settle out, the biggest particle, which is
Sand.
will settle out first. And within the first 60 seconds, you'll see that layer of sand. The next one is the next size particle, which is
Silt.
and finally,
The clay.
the clay will settle out. If you look here, you can see the organic matter floating on top. When you first add the water, the organic matter always floats, but after a couple of days, it'll settle to the bottom. And here you can see the layers. Each soil is a different color, and so you'll see different colors of layers. But if the parent material is very close, then you may not see those layers very carefully. That's why you have to time it when it settles down. But if you really want to test soil textures, you've got to feel them. And here we have 3 different samples. Remember, there was sand, silt, and clay. Not only are the particles different sizes, but the particles feel different. And so we'll take, first of all, our soil samples, and let's see if you can figure out which one is which. You've got to do it with water. Because if you don't do it with water and just feel it, you say, oh, that's kind of bumpy, that one's kind of bumpy, and they all feel the same. But when you add water, it'll make a big difference. Let's start with this one right here in the middle. Just going to wet it down. Wow, look at the water move through that. Now let's put some in your hand. And some in yours. Now rub it between your fingers like this. What do you feel?
Sand.
Is it gritty? Feel hard particles a little bit like sandpaper? We would say that this is a sandy sample then.
This is fun.
Yeah, it's really fun to play in the soil. But let's put this sample back into the bowl and rinse off our hands. I brought a bucket. And all we have to do is dip our hands in here real quick so we don't contaminate the rest of our samples to test the next one. Okay? No flicking, though.
Oh, sorry.
All right. Let's try this one. Let's have your hand. Put just your hand like this, other hand, because you're right-handed. There you go. What you're doing is you're just feeling it between your finger and your thumb to see if you can feel any grittiness, or what silt feels like is smoothness. Ooh. What's it like?
It's like mud.
It's like mud. All soil is mud when it's wet, but this is special mud because it's a different feeling. Do you feel any grit in there like you did before?
No.
Oh.
There's no grit. Is it smooth? Is that a little bit like baby powder?
Yeah.
Kind of.
Kind of like baby powder. It's what? It's silt. That's right. It's silt. And silt will feel smooth, and it's the sort of stuff that you feel on the bottoms of lakes sometimes when you're at reservoirs and it squishes up between your toes. Well, it really sticks to your fingers, and it kind of stains them too. And it won't be as easy to get off as the sand, so we'll have to rub our hands on the edge of the bowl. Now it'll be a little bit more difficult to get off too, even when we stick our hands in this bucket of water. It's really important when you're testing soils to rinse your hands between, because if you don't, you'll contaminate the next group. So get it all off, but no flicking.
Okay.
All right, is everybody clean? We don't have to dry them between each one because we're just going to get them wet and muddy again. We won't dry until the last sample. All right. We've already moistened up this little ball of mud. But let's find out what's so special about this ball of mud and what kind of particles it might have in it. Go ahead and put that between your fingers. See if you can feel any grit in there. You might feel a little bit at first. Work it between your fingers. Sometimes it takes a while with some particles. You have to really push it between your fingers and work it a little bit, especially if it's a clay sample, to get it to break apart. Now, do you feel any grit in there, Zach?
Kind of, not like the first one.
That's right. There's always going to be a little bit of grit and probably a little bit of smoothness because no soil is really totally pure. How does yours feel?
Really sticky.
That's right. Clay will feel sticky. And that's how you can tell if you've got a lot of clay by if it's the more stickier it is, the more clay it has. And so you work that between your fingers and it just sticks all over. You might say it's still a little bit smooth, but when that smoothness runs out, it really grabs. Again, this is a difficult one to get off your hands, so you've got to kind of get it into a ball and scrape it on the edge of the bowl. And then finally, rinse it all off. Most soils are not purely sand, silt, or clay. Most soils are a mixture of the three. We call this mixture a loam. But the soil ingredients do help to name the soil. For example, if you have a soil that has mostly sand, but you can still feel the smoothness of silt and the stickiness of clay, then you have a sandy loam. Or if the soil sample is very sticky, but you still feel some grittiness, you may have a clay loam. By feeling the soil and using the water or mud shake test, soil scientists determine the soil texture name. The texture names are on the soil textural triangle. If you mark your percent of sand, silt, and clay on the appropriate side of the triangle, then draw lines in the noted direction. Where the lines meet or intersect, you will find your soil texture name. Scientists have found over 7,000 different types of soil on Earth, and in fact in Utah we have over 3,000 types. It can be anything from the red soils of southern Utah to the very dark rich soils of northern Utah. And in those soils, remember, the color is determined not so much by the particle size, but by the parent material. The color of the minerals that was in the parent material determines the color. It doesn't have anything to do with the texture. And the best way to determine texture is the way that you folks just did, and that was by feeling it. Farmers need to be familiar with the texture of their soils because different crops do better in certain soils. It's all a matter of water. For proper irrigation, farmers need to know how much water their soil will hold and how their fields will drain.
Soil textures determine how and where homes, buildings, roads, and bridges are built.
So, are you wondering what type of soil you have in your yard? If you want to know, collect a sample in a Ziploc bag and send it to a soil lab. It may cost just a little, but you'll know a lot about what you need to do to help your plants grow best.
We've learned a lot in the last several years about how to take care of our soils so that people, plants, and animals can continue to live there.
But it wasn't so long ago that people didn't care much about our soil.